In today's lesson, we'll be learning about the exponent rules, with a focus on the product rule. The most common exponent rules are the product rule, the quotient rule, the power rule, the negative exponent rule, and the zero exponent rule. Today, we'll be focusing on the product rule. In a previous lesson, we learned that a term typically contains three parts: an exponent, a base, and a coefficient. This is an exponent. Positioned directly below it is a base, and positioned directly beside that base is a coefficient. In our first example, we have two terms multiplying one another. This dot is just another way to represent a multiplication sign. The first thing we want to take a look at are the coefficients. The first term contains a coefficient of positive 3. The second term contains a coefficient of positive 2. We want to multiply coefficients. Therefore, positive 3 times positive 2 gives you positive 6. Next, we want to take a look at bases. The first term doesn't really have a base. The second term has a base, that is the variable of x. Bases stay the same. Therefore, this variable of x stays the same. Last, we want to take a look at the exponents. The first term doesn't really have an exponent. The second term has an exponent of 2. We want to add exponents. Since the first term has no exponent and the second term has an exponent of 2, there's nothing for it to really add to. Therefore, that 2 is going to remain the same. Therefore, 3 multiplied by 2x to the power of 2 simplifies to 6x to the power of 2. In our second example, we have two terms being multiplied by one another. Again, this dot is just another way to represent a multiplication sign. The first thing we want to do is take a look at the coefficients. The first term has no coefficient, but if there is no coefficient, that just means there is a hidden 1. The second term has a coefficient of positive 4. We want to multiply coefficients. Therefore, positive 1 multiplied by positive 4 gives you positive 4. Next, we want to take a look at bases. The first term contains a base of the variable x, and the second term contains a base, also the variable of x. Bases stay the same. Therefore, that variable of x will stay the same. Last, we want to take a look at exponents. The first term contains an exponent of 2, while the second term contains no exponent. If there is no exponent, that just means there is a hidden 1. We want to add exponents. Therefore, 2 plus 1 gives you 3. Therefore, x to the power of 2 multiplied by 4x simplifies to 4x to the power of 3. In our third example, we have two terms being multiplied by each other. Again, this dot is another way to represent a multiplication sign. The first thing you want to do is take a look at the coefficients. The first term contains a coefficient of positive 5, and the second term contains a coefficient of positive 4. We want to multiply coefficients. Therefore, positive 5 multiplied by positive 4 gives us positive 20. Next, we want to take a look at bases. The first term contains two bases, x and y. The second term also contains the same bases of x and y. Bases stay the same. Therefore, the x and y will stay the same. And last, we want to take a look at exponents. The exponent for this base of x is 2, while the exponent for the same base of x is nothing. That just means there's a hidden 1. And we want to add exponents. Therefore, 2 plus 1 is going to give you 3. And that 3 goes above the base of x. We need to repeat the same process for the base of y. The exponent here is 3, and the exponent here for the same base of y is nothing. That just means there is a hidden 1. And we want to add exponents. Therefore, 3 plus 1 will give us 4. and that exponent of 4 goes over the base of y. Therefore, 5x to the power of 2, y to the power of 3, multiplied by 4xy simplifies to 20x to the power of 3, y to the power of 4.